Hello everyone, welcome to solve this math Olympiad algebraic problem, and here we have m cubed plus n cubed equals to 35, and we find the values of m and n according to the given conditions. M and n must be the positive integers, and our m and n is not equals to 1. So now here we first focus on the given question statement, and we have m cube plus n cube equals to 35. So that here we use the nice cubic formula. We know that about cubic formula, so we will use it here, and it will becomes a cubed plus b cubed, or m cubed plus n cubed. It is equals to m plus n times of m square minus m times of n plus n square, and this whole equation equals to 35. And now in the next step, you focus in the left hand side, and you see that we have two factors. These are multiplied by each other, but now here we first make the relation between these two factors. So we know that our first factor is always less than our second factor, so we just write it here. M plus n is always less than m squared minus mn plus n squared. So now here we make the factors of 35, and we choose those factors who satisfied this condition. Our first factor is lesser than the second factor. So now first we find the possibilities in which we get 35. The factors of 35 are 1 multiplied by 35, it will becomes 35, and the second possibility is 35 times of 1 is also 35, and third possibility is 5 times of 7 is 35, and 7 times of 5 is also 35. So now we choose the factors, we choose those factors which satisfied this condition. So here you first focus on this condition, and we have our first factor is 1 and second is 35, and you check here 1 is you see that 1 is less than 35, so it fulfills this condition, so that we choose this factor. And in this case you have 35 and 1, and you see that first factor is greater than second, so we cannot choose this. And similarly here you see that 5 is less than 7, and we will choose this factor. And here you have 7 is greater than 5, so we cannot choose this factor. So we have two possibilities, 1 times of 35 and 5 times of 7. So now we convert here two cases. So first we write our case number 1. So in case 1 we choose our first possibility, and we compare the left hand side with this pair, so that here you easily get the value of m plus n equals to 1, and the value of m squared minus m times of n plus n squared equals to 35. So this is our case number 1. And now here first we write our second case, and after that we use or we solve these two cases one by one. So our case number 2 is we compare the left hand side with this pair, 5 times of 7. So you get here m plus n equals to 5, and our the value of m square minus mn plus n square equals to 7. So we have these two cases, and now we solve these two cases. So here first case 1 implies, or we just solve our case number 1. So our case number 1 is m plus n equals 1, and m square minus mn plus n square equals 35. So now here we just take the square on the first term, and when we take the square on this term on both of the sides, then you get here m square plus 2 times of mn plus n square equals to 1. So when you take square on both of the sides and we open the square in the left hand side, then you get its output in this form, and we have the other value is m square minus mn plus n square equals to 35. So now we subtract these two equations, and when we subtract these two equations we change its signs and we get it here. So you see that these are cancelled by each other, similarly these are also cancelled by each other, and we get here 2 times of mn plus mn equals to 3 times of mn equals to 1 minus 35 is 34. So you get the value of m and n equals to minus 34 by 3. But here we have a contradiction, because in the given question statement we have the restriction is over m and n must be positive integer. So if m and n are positive integers, so that its product is also positive integer, but here it is not positive integer, so that we will reject it this case, and we can just proceed here of case number 2. So in case number 2, here first we call this as equation number 1 and this as equation number 2. So in case number 2, so first I can just copy down here our case number 2 implies that first we copy down case number 2. So it is m plus n equals to 5. Now we call this as equation number 1, and m square minus mn plus n square equals to 7, and we call this as equation number 2. So this is our case number 2, and now we can solve the case number 2 and we find the values of m and n. So here first we focus on equation number 1. So from equation number 1 we find the value of m, and we move this n to the right hand side, and it will becomes m equals to 5 minus n, and we named this as equation number 3, and we put the value of m in equation number 2. So we put in equation number 2. So when we put the value of m in equation number 2, it will becomes here 5 minus n whole square minus the value of m is 5 minus n into n plus n squared equals to 7. So now here we focus on this equation, and we easily get the factors of this equation. So now first we open the square of this term, and we get here 25 plus n squared minus 10 times of n, and we multiply this minus n on these two terms, and we get minus 5n plus n square equals to 7. So here we add or subtract the like terms, and we have n square plus n square plus n square. It will becomes 3 times of n square, and minus 10n and minus 5n equals to minus 15n, and we have this 25, and we move this 7 in the left hand side, it will becomes 25 minus 7, and this whole equals to 0. So now we simplify the terms, and we get 3n square minus 15n, and here we obtain 25 minus 7 equals to plus 18, and this whole equals to 0. So you see here we have 3 with a common term, so we divide each of the term by 3 on both of the sides, and we get here n square minus 5n plus 6 equals to 0. And now we easily make the factors of this equation, and we have n squared minus 3n minus 2n plus 6 equals to 0. So we take common n, and you get n minus 3, and here we take common minus 2, and we get n minus 3 equals to 0. So here we take common n minus 3, and we have n minus 2 equals to 0. So we have two cases. So first is n minus 3 equals to 0 and n minus 2 equals to 0. So here you get the value of n equals to 3, and here you get the value of n equals to 2. So we have these two values of n. So according to these two values of n, we find the value of m. So we have n equals to 3 and n equals to 2. So now we put these two values of n in equation number 3 in this equation. So we have put these two values in equation number 3. So equation number 3 is m equals to 5 minus n. So when you substitute n equals to 3 here, then you get m equals to 5 minus 3 is 2. And when you get put 2 n equals to 2 here, then you get m equals to 3. So these are the two values of m corresponding to these values of n. So this is the our final answer, in which we have mn equals to 2 3. This is the first pair, and 3 2, this is the second pair. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.